what I want to do is review a variety, just a handful of different problem types, and ask you not for their entire solution, but just for a cue. And what I mean by a cue is, what would be the first step that you would take to solve a problem of each of these types? So I think one of the hardest steps in mathematics problem solving is looking at a problem and sort of knowing what a good strategy is right off the bat, knowing where to begin. I work with a lot of students in tutoring, like I have this problem and I just don't know where to start. Because when you look at our curriculum, we have something like 200 different problem types that make up our course throughout the semester. And that's a lot of different stuff to remember if each one of them is individual and they're not related to one another. But building a library of cues in your brain to at least give you a sense of what's an effective first step is a way to help you access all of those different memories of problem types that you're building up as we go over through the semester. So we're going to look at 5 different problem types, and I'm going to ask you real quick, in multiple choice basis, what would you say is the most effective first step for each of these problems? I'll have you take a quick vote, and then we'll take a look at what I think the most effective first step is, and we'll talk a little bit about why. So here's the first problem. Let's say I want to evaluate this combination of fraction arithmetic. And our options for what is the most effective first step are: find a common denominator for the numbers 6 and 3, or multiply everything by 9 to eliminate the denominators, or find a common denominator for 9 and 6, or multiply the 5 and the 1, and then the 6 and the 3, or to add 7 plus 5. And I'm interested in your quick response to this, so I'm going to ask you in 5 seconds to vote 1, 2, 3, 4, or 5, and indicate it by the number of fingers on the hand that you hold up. So here are your responses. The first thing that the majority of you wanted to do is find a common denominator for 9 and 6. So somebody that said that, tell me why. What is it about this problem that tells you that that's the most effective first step for you? How did you make that determination? So you looked at this and said, in order to add fractions, I need those fractions to first have a common denominator. And that's a true fact. However, right. So there are 2 things going on in your brain here, right? The first one is you saw an addition sign and you said, oh, addition of fractions, common denominator. That's a good instinct. I want you to hang on to that instinct. But don't put that instinct into practice until you've looked at the whole problem first. Because that instinct will help you at some point, but it might not be the most effective first step. In fact, it might be an incorrect first step. Because what do we actually need to do first in this problem? I'm doing 2 things with fractions. I'm adding them, and I'm also multiplying them in this expression. And I know, why do I know that the multiplication has to happen first? What is the rule that tells us multiplication happens first before addition? The order of operations. Parentheses, exponents, multiplication and division, and then addition and subtraction. So where there is addition and subtraction in an expression, it always happens last. And if there's any multiplication or division happening, that has to happen first. It has to happen before the addition or subtraction. So even though at some point I probably will need to find a common denominator to successfully complete this addition problem, the time to do that is not first. The time to do that is after we've accomplished all the multiplication and division and then moved on.
But don't you still have to multiply 1 and 3 though?
1 and 3, well...
1 over 3, you know what I mean? Like, for the 5 and 6?
I agree with that. So what is in this list the most effective first step for this problem now that we've had an opportunity to talk about it?
So 1, I guess? I mean, well... 4. Well, because you have to multiply 5 over 6 and 1 over 3. So
yes.
You have to multiply 1 over 3 by 2. Like,
so
that was that's why I didn't know if I should vote or not, because that was my first step.
Okay, well, yeah. So we now that we know that the multiplication is the first step, which one of the 5 options here accomplishes that multiplication?
4. I mean, still 4.
Step number 4, yeah. So that's the first step that we want here in this problem. And this also gets at another thing. Why is it okay for us to just multiply without having to worry about step 1? So what about step 1? Common denominator for 6 and 3. How come that's not my effective first step? So we don't need a common denominator when we're multiplying fractions. Right? We only need a common denominator when we're adding or subtracting fractions. Now, it doesn't hurt to find a common denominator before multiplying, but it will make your life nastier. If I were to change 1 over 3 into, let's say, 2 over 6.
Yeah.
Right? And then multiply across, which is, after all, multiplying across is how you multiply fractions. 5 times 2 will give me 10. 6 times 6 is going to give me 36. And that's okay. I mean, that works. But the problem is 10 over 36 is probably, before we are done with this problem, going to have to be
Yeah, just break it
simplified.
down.
It's going to, right, we're going to reduce it back down. It's going to become 5 over 18. Just dividing top and bottom by 2. And 5 over 18 is what we would have gotten just by multiplying these across in the first place without finding a common denominator. So multiplying or dividing fractions, we don't need a common denominator. If anything, common denominators can get in the way. So in any problem involving a bunch of arithmetic, even if that arithmetic involves fractions, remember the order of operations. Addition and subtraction, where present, will always happen after multiplication and division. So that's one really important cue.